one of the things you can do with scatter plots is write an equation to represent the data. Now, when you all graphed the data that we collected from the United States population, the data did not go in a straight line. But, for example, we could draw a line to represent the trend of the data. Then we could write an equation for that line to predict what the population will be in future years. Why would it be important to predict future populations? Why would that be useful? Brendan? Yeah, to see how much stuff we need. So, I mean, what sort of resources do we need? Do we need more farms to get us more food or clothing or housing? Okay, whenever I see a lot of buildings being built, I think, who's going to buy those? Like, are there people here that really want to live in this area? Are there people who are going to buy all these food from these grocery stores? So population studies are very important to find out if we need and what we need for the future. So that is a very, very solid point. And so writing an equation that represents data is a huge branch of mathematics called modeling. And linear, which is a straight line, is one type of modeling, and we're going to learn all sorts of different equations to model data. And so when you have an equation with two variables, and they generally choose x and y, and x and y are not squared, you notice x is to the first power and y is to the first power, and a and b are not zero, what is going to be graphed is a straight line. So because a and b can both vary, that's why we get an infinity of answers, okay, where x can equal any number, and you plug in x, and then you can solve for y. So today we're going to talk about one method of graphing equations, and then we're just going to expand from there. Graphing lines is a huge topic in Algebra 1, and then by the time you get to Algebra 2, that particular topic should be pretty solid by the time you get there. But we'll graph more than just lines. We'll do other things as well. What's that? I'm sorry, I thought you said something, no? No. Okay. All right, so today we will learn graphing by what's called the pick-a-point method, where you generate a table of values and then connect the points in a straight line. That is the method. So if you have an equation, you create a table based on the equation, and then you connect the dots. If you do it correctly, the points should form a straight line if the equation is a linear equation. And again, linear is when x and y are to the first power. Also, there's no square roots. X is not an exponent. We can do a number of things to make it not a straight line, but if x and y are to the first power and there's nothing else being done to them, when we graph it, you should have a straight line if you do your arithmetic correctly. So we're going to be focusing on that for now, and then we'll go to more difficult things in a little while. So let's see. This would be a straight line because notice y is to the first power and x is to the first power. It's just 2x minus 1. So one of the things we can do with this, or this is kind of just an exercise, where they give us one of the values in an ordered pair, and something I saw when I was looking over your homework from, I think it was Wednesday, when you write an ordered pair, make sure you put a parentheses around the ordered pair. That notation indicates that that's a point on the coordinate plane. What comes first when you do an ordered pair, everybody? And x. So this is telling you that the x value is -3. And they want you to complete the ordered pair, meaning find the y value. So if you plug in -3 for x, how about you guys go ahead and find y, and I'm going to go ahead and check it on your paper. So if x is -3, use the equation to find y. Now, after you find the y value, write it, make sure to write it as an ordered pair, okay? So you can fill in the ordered pair. Now, as you wait for me to come around, have that graph sketched so you can eventually graph the line. So I see everyone got a -7. Now, here, are you given the x value for the next one? No. So you're given the y value. So if you're given the y value, you have to plug it in on the left side of the equation. So how do I find x?
Oh wait, no, first you add 1.
First you add 1. So if you're given y, you actually have to solve. You can't just evaluate. You add 1, and then is a value divided by 2. So x is going to be 1/2. Okay. Now I want you to find the third point. And after you find all 3 points, I want you to graph them on your coordinate plane. And again, because x and y are to the first power, they should form a straight line. So we can test our graphing ability and our algebraic ability and see if they form a straight line. If you are like me and love right angles, you may want to grab yourself some graph paper if you haven't already done so. Dot paper is also nice. This is just like graph paper, but you create the lines, but the right angles are just there already. So I actually do, when I take a math class, all of my paper is graph paper, so it's just ready to go. But we're going to be doing a lot of graphing until the end of the semester and then into next semester. So if you want to switch over at this point, you can. Let's try -3, or does anyone want to graph the point? Brennan? And again, if you don't have your own ruler at any point, you can get up and grab one from my drawer. Just be sure to return it.
Oh, what?
Well, the line represents all the points on the graph. Do you want to use the line tool?
Yes.
So, ooh, this is a new thing where if you do this, and, line tool. So, no, that's not it. Maybe it is. No. It's the line. Okay. There you go. And then, when you draw lines, make sure you extend them to the edges of your graph. And if you want to be super kind of specific, you can make arrows at the ends, because these lines go to positive and negative infinity. Because you can plug in any number for x. X can be a million. So, you know, the x-axis goes all the way to, you know, Colorado, right? It goes all the way west. And the y-axis goes all the way down to the southern hemisphere. So, here we go. That's fun. Any questions there? All right. So, here we go.
Oh, yes.
All right. No, that's all right. So, how many points do we need to write the equation of a line? Yeah. Okay. Just 2. Why would you want to make 3? Is there any argument for doing 3, Isabel?
You want to make sure like, right?
Yeah, I agree with that. Because if you make an algebraic error somewhere, and you only do 2 points, you're not going to know that you made that error. But if all 3 points are collinear means fall in a straight line, then you're like, heck yeah, I got it right. It's really satisfying. All right, so we have this equation, 3x plus y equals 2. And what I have done is created a table of values. In reality, I should be using lowercase x and y. The computer just keeps auto-correcting to capital X and Y. And what I'm going to do is create a table of values. Instead of them telling me what ordered pairs, I'm going to create a table of values. Now, it says to choose 5 values. It's a bit of an overkill, so maybe I'll just choose 3. It's really up to me. But since I'm choosing x values, it's going to be easier for me to solve for y. So if I get y by myself, this is going to be a faster process. So if I subtract 3x on both sides, I get y equals, and generally people write the term with the x first. It'll make a little more sense than a little bit y. And then since the x is positive, it's plus 2. So this is my equation for y. Y equals negative 3x plus 2. And I'm just going to follow the directions, plot at least 5 points. So it's good to pick x values that are both positive and negative, so you get both sides of the y-axis. So I'm going to pick negative and positive x values, and again, a lot of people suggest between negative 2 and positive 2, but you could go like negative 5, negative 2, 0, 2 and 5. It's really whatever's clever. I always like to pick 0 because it's easy to plug in 0. So you can do this in your head, or you can write it down. So if you plug in negative 2 for x, well, I'll let you guys do this. You can do it. Plug in your points, graph them, see if they're collinear.
Who wants to do 5? And-
bunch of different negatives, positives,
Okay.
and not.
Okay.
Yeah, so one of the things I love about graphing, especially like this, is it's easy to know if you're right. Because if your lines don't go in a straight line, it's like, uh-oh, what happened? All right. Denise, did you happen to plug in -2?
Yes.
What did you get?
-4 for y.
So explain to me how you did that.
So I got -3 times -2.
Okay.
Which gives you a +6.
Okay.
And then you add the 2 and you get, oh, wait, sorry.
Okay.
I read the wrong color.
That's all right. Okay. So Lisa, did you do -1? What'd you get?
5.
5. Ashley, did you do 0?
Yeah.
What'd you get?
2.
Davian, did you do 1? What'd you get?
Wait. You want me to redo?
Okay, just tell me what you did.
I did one time. Oh, okay, I see that. Okay, I did one time -3, and then I added 2, so
Okay. Isabel, did you do 2? -4. Now I want you guys to wow. Sorry, I'm kind of littering little segments all over the place. Do you see a pattern for the y values in my table?
Yes.
What's the pattern, DJ?
It goes down by 3.
It goes down by 3. So -3, -3, -3, -3. Do you see 3 anywhere in the equation?
Yes.
Oh,
-3. -3. Oh, -3. Oh my.
So, if your x's are going down by 1, or a consistent amount, the y should go down by a consistent amount as well. All right. And here we see it showing up in our equation. So we're going to try and pay attention to that, see if that's consistent. So does anyone want to graph the points? Okay, Isabel?
Should I grab one?
Sure. Oh, we have time. So Isabel, if you use your finger, it will be a Latin tool, apparently.
It might be outside of like Mr. Raccoon's smartboard.
No, mine's good.
Mr. Raccoon's smartboard.
You should read it.
Yeah, he does every time. And he has to do it a lot. And it's only the smartboard. Right, so then yes. Well, technology. Oh, wait,
Okay. All right. Any questions? That's kind of handy, having your finger as a line tool. Okay. This one, and then what do you think you do first to, well, is this going to be a straight line?
yeah, no. No. Yeah, it says it's
What would tell you?
it'd be a straight line because there's no, it's
The power of 1 to both x and y?
Yeah.
Yep, no square roots, no absolute values.
Yeah.
Okay, should be straight. Okay, so how about you guys create a table, pick some points. Do you think we ought to solve for y?
Yeah.
I'll leave it up to you.
Wait, what number should we do? Yeah.
What numbers do you want to choose?
3. Like,
Definitely, I would pick numbers that are on the graph. Because if you pick numbers off the graph, life gets a little harder.
How many do you want? 5, 3.
Should we do correct?
Miss Madeline, how many do you want?
Minimally 3.
Like
Wait.
0 to 1.
I like doing negative and positive, just so you get both sides of the x-axis. I always like 0. I would do a negative, a positive, and 0 if you're going to do 3. So you get both sides of the y-axis. Well, do you think you ought to solve for y? Last time we did, it's really up to you whether you think that will help you.
So if you divide the 8 by the 2, do you have to multiply the 3x by the 2? Yes. So it's 3 times that.
This one causes some wrinkles. Yep. So, I would like someone to share their strategy. Ashley.
So should I start from what I did?
Yeah, how did you start?
Okay, so, I divided, first I did plus negative 3x, and I added 3x to both sides, and then I divided by 2.
So you decided to, what was your goal?
Well, I didn't really want to multiply it with 2 and 3, so I just decided to do it over a fraction instead.
So your goal was to do what with the equation?
Isolate 1.
Okay, so you wanted to get y by itself?
Yeah.
All right. Then what was your next step, Ashley?
I divided by 2.
Did it look like this when you divided by 2, like the whole thing?
No.
Okay, just like this?
Yeah. And then
Like that?
yeah.
Okay, so tell me what you had.
I got y equals 3 over 2x plus 4.
Did anyone else decide to isolate their y? You did, okay, so, and you did. So a handful, not necessary, but definitely an option. Okay, what did you do next, Ashley?
I grabbed the x and the y, like I need the, whatever it's called,
The
so
table?
the chart.
Yep.
So for x, I just did 2, 4, -2, and -4 because those were the simplest ones to do. And then for 2, I got 7.
Okay, so let's just, can you explain to me real quick why you chose even numbers? Why you thought those were simple?
Because 3 over 2, you have to multiply over, for like 2, you have to multiply 2 over 1, and then those cancel out, which gives 3 over 1.
Okay, so if you multiply by 2, Ashley saw that these canceled, and so tell me what you got again?
7.
7. Okay, and then describe to me what you got here when you plug in 4.
I got 10.
10. So how did you do the 3/2 times the 4?
Well, the 4 would change into a 2 because those are canceled.
Okay.
And then you multiply 3 times 2.
3 times 2?
Yeah, 6.
6.
And then 6 plus 4 is 10.
10. Okay.
And then for -2, you, the 2's cancel out and you get -1. And 3 times -1 plus 4 is 1. And then for -4, you do 2 times -2, and that cancels to -1. Wait, 4. Wait, okay, 2 times -4, and that cancels to -2. So 3 times -2 is -6, plus 4 is -2.
Okay, and I'm just going to add one more number to this. 0, because 0 is always easy. What do you got when you plug in 0?
4.
4, yeah. Okay, so not necessary to solve for y, but Ashley chose to do that. If you had any of these x values, you should have these y values. So that could be a way to check your algebra. Another thing to keep in mind is she made it easier on herself because she got the fractions to cancel, again, by plugging in even numbers. So Ashley, do you want to come up and graph? We can see if it forms a straight line. Oh, this is. Let's see, 2, 7. I think it's 4, 10.
Yeah, do -2, -1.
Wait, for what?
Oh.
It's -2, -1, so only one.
Okay.
There you go.
Okay.
Throw the other arrow, Ashley.
All right. Any questions for Ashley? All right.
So that, wait, that -2 and 1 is supposed to be.
It's supposed to be 1.
Okay.
Yeah, because -3 plus 4 is going to be a positive 1. Okay. Now, does anyone have any questions if they chose not to solve for y on what they did? Davian?
No.
Okay. Because you don't have to. You can keep it as 2y minus 3 plus 8, and you can plug in y values or x values and solve. It's your choice. And you don't have to pick that many values, but the more values, the more you can kind of confirm that you, the more that you, okay. So there is your assignment. It looks like a lot, but in reality, I cherry-picked some problems, so.
I was there just.